And then, yeah, do whatever.
Why do you run? You never get away from it all. Just turn your back. You'll never hide away from it all. You'll always put your face to the wall, afraid to fall. If you're standing tall, you never had your back to the wall. You had it Why do you lie? Then you show your face to us all. You shut your mouth. You see me stand here, watch while you fall. You always put your face to the wall, afraid to fall. You're standing tall, but you never had your back to the wall. You've had it easy. Why do you cry while you shake your fist at it all? I point and laugh, kick you while you're trying to crawl. You always put your face to the wall, afraid to fall. You're standing tall, you never had your back to the wall. You had it easy. Had it so easy. Yes, you had it so easy. And we had it so easy. Why ain't my life that easy? You had it so much time has passed, and I have reached the last point of my points. The end has come. This is the final act, in which my role's defined, a servant to all who find myself to be lonely compared to them. This is the final act, and this is the end. This is the final act, this is the end. Eyeballs give me tight, try to struggle, cannot fight. I wanna leave my legs to the side. No freedom till the day I die. No freedom till the day I die. Then they realized my life was not paralyzed. I had my share of work, but now it's through, no more to do. This is the final act, the end has come. This is the final act, the end has come. Eyeballs grip me tight, but I've broken them tonight. I can breathe again, I had to leave. My legs were tied, I had to leave. My legs were tied. 10 long years until I die. 10 long years until the day I died. Too much time has passed, and now I've reached the last point of my points. The end has come. It's the final act, in which my role's defined, to serve to all who find myself to be lonely compared to them. This is the final act. This is the end. This is the final act. I said this is the end. Eyeballs grip me tight, try to struggle, cannot fight. I wanna leave, my legs are tied.
I don't know, man.
Early one morning, while making the rounds, I took a shot of cocaine and I shot my woman down. Went right home and I went to bed. I stuck that 1144 beneath my head. Got up this morning and I grabbed that gun. I took a shot of cocaine and away I run. Made a good run, but I run too slow. They overtook me down in Juarez, Mexico. Laid in the hot joint, taking the pill. In walked the sheriff from Jericho Hill. He said, Willie Lee, your name is not Jack Brown. You're the dirty hack that shot your woman down. Oh yes, my name is Willie. If you got a warrant, read it to me. Shot her down because she made me sore. Was her daddy? I thought it was a daddy, but she had 5 more. When I was arrested, I was dressed in black. They put me on a train and they took me back. I know a friend who'll go my band. They shot my dried up carcass in the county jail. Next morning, about 9:30, I spied the sheriff coming down the line. Up there he gobbled as he flared his nose. He said, well, come on, you dirty hack, and to the district court. To the courtroom where my trial began. I was held by wilderness men just before the jury started out. I saw that little judge come as to look about. In his 5 minutes, he walked a man on the verge.
Hello, everyone. Thank you for coming to this workshop where we're going to be showing and talking about how to build Gen AI applications with the new Gen AI stack that we put together. My name's Harrison Chase. I'm the CEO and co-founder of LingChain.
And I'm Michael Hunger, Head of Product Innovation at Neo4j. So you might have seen us this morning in the keynote. And what we want to do now is go a little bit deeper into the whys and hows, what's behind the scenes, what does the actual code look like, how you can get started, and so on. OK, so this whole Gen AI Stack initiative has 4 partners. It's LangChain, Neo4j, all orchestrated by Docker and Olama for the local LLMs as such. Just to give you some background, let's talk about LLMs and Gen AI in general. Who has not yet used an LLM of you? One? OK, so you probably, or two, probably most of you have used ChatGPT in some form or another. So LLMs are a part of the new type of foundation models that are used to have been trained on a large amount of data to basically predict information. So traditionally, machine learning models were like in the realm of very smart data scientists who trained models for very specific purposes. So for instance, you had like a legal model to analyze legal text, or you had like image recognition model to recognize certain parts or certain types of objects in an image, right? And this meant you always had to fine-tune or train models for very specific purposes, and you always had to put in a lot of specific effort by data scientists to make this happen. With foundation models, all is shifted because they basically say, OK, let's just train models on a massive amount of data and then use a prediction mechanism basically to say, OK, based on this data, it's kind of almost like world knowledge that these models learn. How can the inputs of the users, either as text or images or videos, be used to, for instance, generate information, detect things, extract information, and all the other things, right? And the really cool thing about this is that these models are now available to developers, right? You don't need to be a data scientist anymore. We'll talk a little bit about this later. And it all started 2017 in with the transformer architecture and from Google, which allowed us to kind of train these kinds of models. And the training volume has gone up quite a bit. So these large models have been now trained on trillions of tokens of information. And you have models from every kind of provider, right? From Google, from OpenAI, from Amazon, Anthropic, and many, many other. Meta, of course, with Llama 2. So there's a lot of models out there, right? And what's kind of interesting, from a certain training size, suddenly these models started to show emergent behavior, right? So up to a certain level, you kind of could expect what they would produce, but from a certain training size, there was like a threshold where suddenly it felt like more, right? So as if there was almost some level of understanding or some level of pseudo-human interactions possible, which is what we now see today in GPT-3 and 4, for instance. Right? And what's really interesting as well is these models now can hold conversations. They can keep previous context. They can work with larger context windows and things like that, which allows you to build much more natural working applications on top of them. Right? So why are they so hot right now? You can do a lot of stuff with LLMs. They're more like a general purpose tool, like a calculator or a computer in some way, right? So it doesn't mean that an LLM will replace you, but it makes you faster, more productive, or smarter in some way as well, right? So you can automate a lot of data retrieval tasks with LLMs. You don't need to go and train a specific model to extract data information from things. You can improve the end-user experiences both inside of your organization, but also outside. So for instance, if you have databases and in the past either people had to get apps written or write SQL or whatever query language themselves to access the data, now you can open this up to more people asking just natural language questions of your data, which is really, really nice. And of course, we are kind of all drowned by information. And so LLMs can help us, or foundation models can help us to make more sense or quicker summarize this information. Of course, there's a trap, right? So if on one side, LLMs are used to generate information. On the other side, it's kind of used to summarize information again. Could also just send the condensed version of the information. So there's also a lot of traps in the Gen AI space. And especially for us as developers, code generation is really cool, right? So many of you might have used Copilot, but there are also many other tools like Duet. There's SQL generation from natural language, or for us, for Neo4j, Cypher generation from natural language. So there's a lot of stuff that we as developers can do better. Simon Willison had a really good article where he said basically, it enables me to do things that usually would have taken 5 days and takes it down to 2 to 3 hours to build new things that I have not yet used before. There are some challenges with GenAI, right? So one is kind of the hallucination parroting, right? It just makes stuff up instead of saying, I don't know. The reinforcement learning with human feedback basically made these models more to, oh, I always have to please the human, right? So instead of rather saying, I don't know, they very convincingly generate information, links, and other things, even if it's all fake. So that's a big problem because you don't want to put such a system into your application or into your enterprise, right? So you want to be able to trust these models. And then training data cutoff is a big problem, right? Because all these trained models go to a certain day. And what happens with all the information that was later, right? Or how do you access your own private information that sits in your own databases with these models? It's currently not possible. You have some plugins for accessing web and other things, but what happens with your databases as such, right? And then you have the whole security compliance, PIA, and so on, right? So they're great at language understanding, and that's what we kind of use them for. So we basically just use their language skills, and we completely ignore all the training data that they have been used on. So hallucinations, again, very confident, making stuff up. Sometimes like me talking about stuff, right? Like imposter syndrome type. I already mentioned most of these. There are also all the ethical aspects, right? Where did the data come from? Have people been compensated for instance, authors and artists for using their data for training? How do people or large companies label their data, right? So there's the whole labor and exploitation aspect. So there's a lot of stuff. There's also injection, right? Prompt injection is a big topic that's totally underserved. So there are lots of challenges that exist as such that need to be addressed kind of one by one by us. But in general, I think in the end, it will be more beneficial than negative. So I'm not on the negative side. So all these challenges with LLMs, how can we make it better? So there's some options. You can either take an existing model and fine-tune it, but it's a lot of effort, and oftentimes the outputs and results are not, at least today, not there yet where we want to take an existing model and fine-tune it. You can provide a few examples when you talk to the LLM, but then you basically have to hardcode these examples, which is kind of not really helpful. And then there's grounding or retrieval augmentation, which we'll go into, which is basically you provide the LLM with the information that it should use to answer the user's question, and you just use the language skills of summarization to get there. So, but there's really good opportunities for developers that.
Yeah, and so one of the most exciting things about this world that we live in now is that you don't have to be a data scientist to interact with these really powerful machine learning models. A lot of the main ones that people are using are just behind APIs. So OpenAI is behind an API, Anthropic's behind an API, and so you can interact with them super easily. And then there's also really exciting packages like Ollama, which we'll be using, which are locally hosted models, but they bundle it up super nicely. You no longer have to train the model, you just have to run it and serve it, and Ollama makes that really easy. So we're seeing this kind of democratization of who can use these large language models. There's some kind of like things, and there's work to be done as well. So it's not like it's a finished project. It's not like, there's nothing left to be done and we're all just going to sail off into the sunset. There's a lot of work that needs to be done to use these language models. So prompting is an entirely new kind of like discipline that's emerged. These language models generally take kind of like text as input and output text, and the output text is often either a response to a user or something that says how to do something downstream. And so it's really, really important to be able to kind of like best get the output text that you want, that yields the best result. And the way to do that is through prompting, where you kind of like carefully construct the string that you're going to pass in to the language model. There's other things besides the prompt that also affect the language model. So these models have things like temperature, which affect how kind of like random they respond. And so if you want like a really deterministic output, or pretty close to a deterministic output, you can set temperature really low. If you want a more creative and variable response, you set it really high. And there's no one that's right all the time. They're useful for different applications. So some of the creative chatbots that we see out there probably have pretty high temperature. Some of the more kind of like personal assistants that really want to do particular things really well have low temperature. And so there's a lot of techniques and triggers that developers can learn and become experts in order to best use these models. And then there's also all of the kind of like using the output of the language model, and that's kind of like where LangChain comes into play a little bit. But the idea is the output may be a text, but it often has more structure than just a text. And so you want to make sure that it's structured in the right way so that you can parse it and process it and maybe use it as input to an API or to run a SQL command or things like that. So there's a lot of work to be done in hooking up these language models to other sources of data and computation. And so I think as we talked about before, there's a wide variety of foundation models which are available. You've got the major cloud providers all jumping in. You've got local models like Ollama, which anyone can run on their own computer. And then there's also AI native startups like OpenAI and Anthropic, which are kind of like at the base layer of a lot of the applications. One level up, you've got orchestration frameworks like LangChain, Llama Index, and Human Loop, which help orchestrate a lot of the language models and connecting them to other sources of data and computation. And we'll show more what that looks like in the RAG app. You've then got infrastructure, which kind of like encompasses all of this. There's deployment, monitoring, eval, tooling. A lot of this is similar to software engineering, but there's also some differences in LLM-specific tooling that's starting to come out. Langsmith, which we showed, is one example of that, but there's a lot of others that are, some are really focused on kind of like monitoring the API responses, some are more focused on the ML side of things of helping you drill down into what people are actually using your chatbot for. And so there's a lot of new tooling emerging in this infrastructure category. And then the last thing that's proven really important, as Michael said, in order to get really good responses, you generally want to have some sort of database that you're connected to and is powering the actual facts of the application. And so there's so vector search and vector databases have emerged as this new form that's proven really powerful to connect to language models, but there's also all the existing databases like SQL and graph databases, which you can still use to provide this context. So looking at this in a little bit of a more broken down picture, you can see here that, so this is from A16Z. It's from a few months ago, so that's why it says partial next to it, because the space changes really, really fast. And you can see that there's this orchestration layer right in the middle, and that's kind of where LangChain sits. But then there's all these other pieces that are all around it. You've got Playground, you've got APIs and plugins. At the top level, you have kind of like the contextual data, so data pipelines, embedding models, vector databases, and if we were to extend that today, we'd also put like other databases like graph databases and SQL there. Then you've got all the kind of like infrastructure in the bottom with the LLM cache, logging, LLM ops, validation. You can even zoom into that more, and then you finally get to the app hosting. So a lot of what we're showing today looks like a pretty simple app at the surface, but we'll show the code and we'll show a lot of these different components behind the scenes. And part of the value prop of the GenAI stack is to simplify this a bit and give you a really easy way to get started with it. So I've talked about LangChain a little bit so far, and so just to dive into that a little bit more, LangChain is a GenAI orchestration framework, so it connects to all these different modules that you see up here. So tools, example selectors, prompts, vector stores, document loaders, output parsers, text splitters, models, probably other ones as well that we're not mentioning here. All of these are different modules in LangChain, and applications generally consist of 4, 5, 6 different of those modules constructed in various ways. And so we provide kind of like a standard interface for all those modules. So we have a standard interface for, I think, over 50 different LLM providers. And then we also have implementation of some of those modules that we do ourselves. So text splitters, for example, are one implementation that we have that's in LangChain that's kind of like native to LangChain. The other value prop of LangChain are pre-built chains and agents. So as I said, a lot of these applications are these modules, or like 4 or 5 of these modules constructed in particular ways. And so we have a lot of off-the-shelf chains and agents that are basically pre-built templates to accomplish a variety of tasks. And so we'll be using one of them today to do the retrieval QA with sources chain, and we can dive into what exactly is going on behind the scenes there. I'm going to hand it back to Michael to talk more about RAG.
So RAG is all the rage today. Right? So as I mentioned, the backing or feeding information from databases or data sources to language model to help users is kind of currently the best way of approaching the hallucination and knowledge kind of thing. And RAG is an acronym that stands for Retrieval Augmented Generation. And that's basically the idea. There was a paper, I don't know, 2 years ago or a year ago or something like that, or even not, 6 months ago probably, where they kind of explored this, and this really stuck with because people saw the value of it. And basically, you ignore the LLM training data, you just use language skills. You can take the user question, you turn the user question either into a vector embedding or into a database query, send it to your database or data source, extract the relevant information for this question, not all the information in your database because it's much, of course, right? But relevant information for this question, and then you send the question with this information to the LLM to produce the answer for the person. Right? So that's kind of the approach that you also see here in this pattern. Sometimes you can even decide, actually, do I need to get to the database to get some information? Like, for instance, if you just want to ask, or if you just have a creative task, like, generate me some ideas for my next project or something like that. So for creative tasks, you can also go directly to the LLM, but for everything that you actually want to access your internal data, then you would go to the database and do this. So the GenAI stack, as we showed this morning as well in the keynote, there are not just the components that we talked about, but also a number of example applications already a part of the stack. We're going to add more to it, and we also, of course, are interested in your feedback. So if you have ideas or questions, feel free to open GitHub issues or send pull requests to the repository as well. So the first app that we have in there is the knowledge graph import that basically fetches data from an API, creates the data in the database, generates the embeddings, stores the embeddings in vector index, and so makes it available for the other apps to use that. The second one that we showed this morning was the chatbot that allows you to either do directly LLM interactions or use RAG with the database. We also have a function in that app that says, hey, if we didn't have the information in our knowledge base to answer this question, then can you pick basically the top or the best rated answers the best rated questions in our knowledge base to generate a new ticket for our internal support team to answer the question. So it will take all the input from the user question plus the tone and style and type of the best rated or highest rated questions in our knowledge base, and then generates a new question in the same tone and style as such. And then the fourth app that we have in there is basically chat to your PDF. You upload a PDF, it's turned into chunks, into vectors, and then you can use LangChain and the UI and stream that to chat to the PDF or ask questions about this PDF, which is also a common example of how you make documents accessible on not databases as such. And again, building blocks for the GenAI stack, as we mentioned several times already. And it's all pulled together by Docker Compose. So there are brand new base images for Olama, especially also on Linux, working out of the box. LangChain based images, both are official images as well, and then the Neo4j official image, which has been around for quite some time, are all put together by Docker Compose setup, which basically orchestrates and configures all the environment variables to which model to use, what is the length connection information, for instance, or what kind of internal, external information do I also want to pull in. Right? So if you look at the flow in the app, this is kind of what we've talked about in the containers, right? So you would basically in the bot, you take a user question in the Streamlit app. So we're using Streamlit as the UI framework today because for Python developers, that's the best way or the quickest way to get to prototypical UIs. So you don't have to have an API and then JavaScript frontend, but you can basically just use directly Python to run your application. So you take the user question, you go to the embedding model to generate the vector embedding for the user question. For instance, you can use sentence transformers, but also Llama 2 or others. OpenAI, for instance, get embedding. You go to the data vector searching database, you do the vector search, and then because it's a graph database, you take whatever the top k elements from the vector search and expand the context. So what else is related to this question, right? What are the top rated answers? Which other questions are related to this through tags and other things as well? And then you take this information and send it to the chat model, which is a different model than the embedding model, through LangChain, and get the answer back, which you then render in the app as such. And let's go into that and show the demo. I'll start, and then Harrison will look at the second part. So as we showed you this morning, you can basically run, so I can run this again here, Docker Compose up. You can also look at the compose file while it's doing things here. So the compose file has a bunch of components in here. So we have the LLM image for the local Olama, managing the local LLMs. We have a pull model image which pulls basically the image from the Olama registry. So depending on which model you want to use, you would pull this model. These models can be pretty big. So the small models like Llama 2, 7 billion is 4 gigabytes. The 30 billion one is 13 gigabytes. And the 70 billion one is 30 gigabytes or something like that. So it's a lot of data. But Olama also holds this locally, so you don't have to reload it. So if you run it, pull it once, then it's on your machine and you can run this. Then database Neo4j with health check here. And then we have our different apps. So we have the loader, we have the bot, we have the PF bot, and that's basically our images that exposing different ports on this machine, and the configuration then passes in either information for local images, or you can also put in your OpenAI key, and then you can use GPT-3 or GPT-4 as models as well. And so meanwhile, our Docker Compose down was successful, and if I start this, it basically pulls up the LLM model, the database, and the apps as well. And while it's doing this, I can show you in the UI, basically we have our loader here that should be running right now. Let's see. So which basically means you can pick any Stack Overflow tag that you're interested in. So for instance, imagine you want to add Docker questions to our database. It fetches the last n pages of questions, all the questions, all the answers, all the users, all the tags, and embeds this into the vector embeddings, and then fetches that. So this should take roughly 10 to 20 seconds to fetch 100 questions, the last 100 questions on Stack Overflow about Docker. So if you ask to answer the question in the last few days, then your question will probably be in here. And it adds it to the graph database. So you see the input is now successful. You can jump here directly with the link to the database. And here you see this, the data model with questions, answers, users, and tags. And if you go to the database, then we can explore this data, navigate through it. So you see in purple the questions, the blue ones are the answers, orange the tags, and then I can say I want to expand, for instance, this tag, and then I see all these other questions as well in here, right? And you can create this database. And so on. And all of them also have like vector embeddings. So when I basically look at one of these questions, then you see here I have the question body, and here you have the embedding data directly attached to your entity, which is then also stored in the vector index for the search as such. Right? And so that's the database as such, and how you can populate it. And it uses basically just a Stack Overflow API call to fetch the data from Stack Overflow. And you can imagine this data can come from anywhere, from any API, from any data source, you name it. Right? And then the bot is in the first mode, when RAG is disabled, it talks to the LLM, whichever LLM you have basically used directly, and then you can say, for instance, how do I use Docker Scout or something like that. Right, and then it shows you the information, and it basically gives you something, but I don't know. Yeah, this should actually be. I think it's Llama 2. It might actually have information about this, but let's see. If you use the question I had today this morning, how do I summarize PDFs using LangChain? Then it says basically, I don't know about anything about LangChain, right? So because the knowledge cutoff was before LangChain was released last November, right?
Yeah, it thinks it's blockchain. So
oh yeah, it also thinks it's blockchain.
By the name.
So it's a really smart choice of name, person. And then you can basically compare this with the same question going to the RAG store. So which basically exactly does what I explained before. It takes your question, turns it into a vector, goes to the vector index, searches the top K documents or elements in the graph database, and then goes from these questions to what are the most highly rated or accepted answers, and passes those questions plus these answers to the LLM to answer our question here. Right? So there's a lot of stuff happening behind the scenes. We look into the code as well. And so this is actually taken from the Stack Overflow articles that are in the database. And one really nice aspect of the RAG pattern is also that you get basically referenceable and verifiable sources back from your answers, right? So it's not just it generates an answer, but if you pass into the LLM also links or URLs or other kinds of sources that your text chunks or your information is basically verified by, then you can tell the LLM in the prompt to use that to basically regenerate these source links when it outputs or summarizes the answer, so you can then use those to go into the detail, right? So then I can just click on one of these links and get my information here, right? And the last application is, as I mentioned, is an PDF chat bot. You can here take Einstein's invention. While I'm looking at, there's also what's this? If I want to. If I'm not happy with the answer from the LLM, then I can also say, generate a draft ticket for me. That's the other app that I mentioned before, which basically takes the top-rated information from the database or the top-rated questions from the database and generates an answer in the style of that question as well. And here we basically uploaded Einstein's pattern inventions and can say list all inventions in the file or in the by Einstein. So, and then it basically takes these text chunks again that were extracted out of the PDF and summarizes it, fetches the most relevant information, and then returns the answer for that. Right. So that's kind of the outside. So all these apps are Streamlit apps. We're going to add also more LangChain.js apps and apps that have APIs and have a JavaScript frontend as well. So this is only like the starting point. And you see basically from the PDF things like that, and including that Einstein decided blouse that was a practical invention rather than a scientific one, which is also in the PDF as well. Right. So if you want to look into the code for all of these, is it's probably also something that Harrison can talk about a little bit more. You have basically functions that, for instance, only use the LLM, which is this one, that have a prompt that says you're helpful assistants to answer these questions, and then uses prompt templates to fill in the human questions as such and the system message question, and then it uses a streaming output. You see that it, like ChatGPT, it generates the answer as a stream, so that's why you have this callback here. That you use, and then it basically invokes the chain with the user input and the callbacks, and then starts generating the answers. So that's basically all the code that you need to do an LLM-only chat. And then if you want to do the RAG one, then we have a more involved piece of code. Here, the prompts are a little bit more involved. We kind of explain what you're seeing and that you have sources in there and links in there. Here in this section will be the summaries from the database query. And then the user question gets passed into the user template as such, right? So it also says each answer should also have a link as well. And we also say if you don't know, then don't try to answer, just say that you don't know. And sometimes, yeah, exactly. So, and then this is taken into system and human templates, chat prompt. And then we see here the vector and knowledge graph integration, where we basically just say from in the LangChain vector store package or part. We can pull in the Neo4j vector store. We can also pull in other vector stores if you want to. And you say basically, this is my vector index. This is the field to look for. And then you can actually provide this graph query, which then goes to the question and fetches related information to pass back to the LLM. And then you combine this all with a retrieval QA chain to combine the QA chain that you configured with the vector store as retriever. I want to have the top 2 elements. You can increase this, but then the amount of text that gets passed to the element gets bigger. And there are some effects of that. So one is that it becomes more probabilistic because it starts, for instance, to ignore stuff in the middle of the prompt and things like that. So 2 to 5, depending on the volume of text that you have in your chunks, is usually good. And then this is our QA chain that we then use to answer the question. So that's kind of the code behind the scenes. And Harrison will look a little bit into how can we figure out what's actually happening while this code is running.
Yeah, absolutely. So the last thing that Michael showed was this retrieval QA with sources chain, which is a class in LangChain which contains a lot of logic for doing this exact RAG-based application. And so that's great because it means it's easy to get started with just that class. But that's a little bit unideal because that class actually contains a decent amount of logic in it. And that's one of the actually simpler classes in LangChain as well. So some of the more complex ones have even more logic inside them. And so as you're building your application, it's great to get started with a few lines of code, but it's really important to understand what's going on under the hood so that you can debug it and improve it and really bring it from a prototype to production. And so in order to help with that, we've created Langsmith, which is a debugger. It does a lot of things, but the main thing that people use it for is this debugging and observability to see exactly what's going on under the hood. And so if we look at we can see here there's actually 3 different types of sequences. So this is the first one. This is just the first LLM call without any RAG things. And this is just a really simple prompt in LLM, so it's pretty straightforward. Just to use this as an example of showing off some of the cool things that Langsmith enables as well, though, you can see exactly what the inputs and outputs to each step are. You can see any metadata associated with it. And then when you go into the LLM place in particular, you can actually open up a little playground and then mess around with it. So you can see the settings over there. You can change the inputs and then rerun it and get an output and basically debug it kind of like live. And this is really helpful when you have a sequence of multiple LLM calls. If you want to try to debug the third one in that sequence, you need to like recreate the exact state that it was in, the exact input variables, the exact prompt template. And so rather than trying to do all of that, independent in your app, you can kind of just easily open up the playground here. Going back to here, we see that there's 2 more types of chains. And these are actually very similar chains, but with just different prompts. And so if we look at this one, the retrieval QA with sources chain, we can see that the sequence of steps, there's first this retriever step, and then there's this stuff documents chain. And so if we look at the retriever step, we can see that what this is doing is taking in a query and returning a list of documents. And so here we can inspect like what exactly are the documents that we're getting back. And we can see them all in here. The stuff documents chain basically takes these inputs. So it's got a question, it's got the chat history, and now it has this input documents. And these are coming from the previous retriever step. And then under the hood, what it's doing is it's passing all of those into a final call to the language model. And so if we open this up in the playground again, we can now see the system prompt, which was what Michael was pointing out earlier. Use the following pieces of context to answer the question at the end. The context contains questions, blah, 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 blah. We get down here, and we now see the content. And it's pasted in here. And then all the way at the end, we see the user question. How do I summarize PDFs using LangChain? And so we can see exactly what this prompt looks like by the time the retrieval step has been done. If we go back to here, we can see that this chain looks basically the same. And so what's going on is the main difference is the prompt that's being passed in. And this is why the prompts were so important earlier, is because they tell the language model how to perform. And so if you remember the difference between this result, where we get the references, and this result, where we don't, the only difference is the prompts. So one prompt's telling it to generate a list of sources and cite its answers. The other one's not asking for it. And so that shows a lot of the flexibility that you can have with this type of prompting strategy. I believe that's it for what I wanted to show in here. And so I think we'll go back to slides for now. And so I think the next few slides are all walking through the details of this application. And I believe we'll share these so you can see in more detail. We're using Docker Compose for a lot of the orchestration. We've got the various containers that are all getting pulled up. Olama, they're upstairs in the booth. They're great. You should absolutely go check them out. We're using their local LLM. These are the other LLMs that we could sub in, should we want to. And all of these have kind of like integrations with LangChains with the same exact interface. So it's very easy to swap them in and out and experiment. I believe there was someone during the keynote who was talking about like the importance of basically this rapid experimentation phase to figure out what you or your company is going to build for Gen AI and actually have product market fit with that. And so that's part of the value prop of LangChain as well, as this rapid experimentation. Neo4j obviously as the knowledge graph here, and I think like one really interesting thing, one like big benefit of Neo4j in my mind is that visualization of all the different concepts that you've got going on. I think a lot of these applications, again, connecting it to your data, a lot of it's throwing the data into a vector store. It's really, really nice to be able to visualize what exactly is in your vector store, the same way that's really nice to be able to visualize what's going on in the chain. And I think like one maybe theme of all these LLM applications is that as you add this like stochastic nature into it, observability becomes really, really important. And so I think that's a big bonus of this Gen AI stack that we've put together, which helps. And so the Neo4j stuff uses the ground LLMs in the knowledge graph. We can see that there is this import step. The indexing step is really, really complicated as well. That's probably a separate talk by itself. There's a lot of different options that go on behind the scenes in terms of how do you reprocess this text, split it into chunks, put it exactly into the vector databases with the different tags, so that you can get this nice visualization right here. The LangChain part, again, kind of like these different components, the ways of constructing the app, and then a few of the applications that were created. First was this support agent bot, which answers based on the question. You've got it's written in Python, the UI is in Streamlit, and it's got it uses the LangChain prompts, embeddings, LLM, and then Neo4j under the scene. And specifically, you've got this like user question that comes in, a QA chain that configures the prompts to provide an output, and then also list out the sources, and then it renders it in the UI. Some more details here on what specifically is going on with the Neo4j vector store. So you embed the question as a vector, you pass it in, you find relevant documents to that vector, and then pass it back. This is the workflow that Michael showed off as well, where you're generating a ticket. So there's no answer in the knowledge base. What do? You turn the user question into a ticket. And this is a really interesting point because I think one of the big things that people are still trying to figure out, and why it's a really good time to be a developer right now, is like what is the right UX for all these Gen AI applications? Because they can be really good and they can be really powerful, but they're not perfect. And so how do you kind of like both communicate that, but then also make up for that with kind of like things that go into the UX? And this is a bit like application specific, which again is why it's a great time to be building applications in Gen AI right now. This is a screenshot from the LangChain documentation that just shows off some of the use cases that we have. So if any of these spark your fancy, I'd be sure to go check them out. There's a lot of different use cases, and there's also a lot of different integrations, and so those are on the other side. And so you can see that we have a lot with all the main kind of like cloud providers, but then all those different components, there's 50 to 100 under each of those for the different types of tools, retrievers, LLMs that you can pull in. Langsmith, as we showed, is kind of like the observability step for your LLM applications. What are the sequence of steps? What are the inputs and outputs of each step? Right now, it's in a private beta, but we've made a code for everyone here today. So we'd love for you guys to try it out, and that QR code should open you up to Langsmith right there. And if you miss this, come see me afterwards, and happy to get you set up. And that enables views like this, where you can kind of see the exact trace and the exact inputs. And so I think Michael's going to talk a little bit now about how you can access all this stuff that we've been talking about.
Yeah. Thank you, Hassan. So where can you get it? So first, easiest way to get it is just open your Docker desktop in the Learning Center, and in the middle you should see under AI and ML guides the Gen AI stack. You click on the link, and it gets you basically to the Git repository that you can clone and get it, download it, run Docker Compose up, and you should be up and running. If you want to add other things, like for instance OpenAI APIs, then there's an .env file that you can configure with your OpenAI key, or if you want to run and use a cloud-hosted Neo4j database, or if you want to change the types of models that it uses, that's all in the configuration. And stay tuned, there's more to come there as such. So please feel free to give us feedback. There's also the Docker AI ML hackathon going on. So if you want to try out the Gen AI stack, this is a really good opportunity. So Docker has a lot of great prizes for the hackathon. It's going on for 5 weeks. So you have plenty of time to get familiar with this, get started, and that's great. Our own developer conference is going on the 26th of October. So if you want to learn more about this graph way of seeing things and connecting information, come by. We have 24 hours of content around all time zones, with more than 100 talks. And ML and AI is a big aspect of that, including also powerful visualizations and so on. And otherwise, thank you. Neo4j and Olama have booths on the second floor. If you want to drill deeper or go more into the code and talk to us about some of these things, feel free. Otherwise, you can also find Harrison or me or any of the other folks that were here this morning to answer your questions as such. Thank you so much. We can also do questions right now, but I don't know if you have a microphone or something. Otherwise, you have to probably yell at us, so feel free to. Yes, so a graph database is, first of all, a general-purpose transactional database that stores information as entity and relationships. So unlike a relation database where you just have tables, you have really like entities as one type of object, and relationships as another one. And a vector database or a vector index in more general is an as an index that takes multidimensional floating point encodings of the essence of information, right? And vector encoding on vector embedding is more like what's the essence of the sentence, or what's the essence of this picture, or what's the essence of this word or video or something like that into a multidimensional vector space. And these vector indexes or vector databases basically allow you to find, for a given vector, like you use a question, what are the most similar or most close other vectors in my database that already exist, either by distance or by angular distance, so cosine or Euclidean distance. And vector databases are basically just very fast algorithms that take large volumes of these vectors that pre-exist and find the closest ones to your input. And there are many vector databases out there, like for instance Pinecode, VV8, and so on. But many of the other databases like Neo4j, Mongo, Postgres, and others have added actually vector indexes to their regular databases. So you get the benefit of having a regular database with all the benefits that you have today, like security, live updates, and all the other things, together with vector search. Right? So if you have a very narrow use case that you just want to do vector search and nothing else, then the vector database is good. But if you have already existing data in your database, then you can use the vector search capabilities of your database as such. Yes.
Yeah.
In that case, do you have any tool or something like that which basically assists you in creating those prompts or suggests you how you could do that a little better?
Yeah, there's been a few kind of research papers in that vein of taking kind of a prompt, asking the LLM to improve it. I think we have implementations of one. There's one called Ape Automatic Prompt Engineer that does that. I'm actually a little bit bearish on that use case because I think a lot of the times when LLMs get things wrong, it's not that there's extra space where there shouldn't be a space or things. Like you look at some of the mid-journey prompts, right? And they have these random characters, right? And there's a lot of kind of artwork that goes into figuring out what sequence of words to put next to each other. I don't think LLMs are quite like that. And I think a lot of the times when they mess up, the real thing lies that they're just lacking the correct context to answer. They don't have the data that they need to be grounded in. The instructions just aren't clear. And so if the instructions aren't clear, it doesn't matter a little bit there. One thing that I am more bullish on excuse me, is maybe the idea of using an LLM to suggest ways that a human, more information that a human could bring to the prompt, not necessarily doing it itself, because I think it's hard for an LLM to automatically bring some of that information in, but saying what things aren't clear. And I'm a bit more bullish on that.
Cool. If you have more questions, just find us afterwards. We need to make room for the next presenter. So just come around and we'll be here. Thank you all.
Thank you,
Thanks for attending. See you around.
Hi, welcome. This is Janakiram. I want to give you a quick walkthrough of the recent announcement by Docker, which is their new AI.
The world of digital logic is a pretty cool place. Everything you touch nowadays has millions or billions of transistors inside it. From your humble watch to your pocket-sized computer, it's transistors all the way down. But what does that look like and how do they interact? Let's take a deep dive into the world of digital logic design and basically build our own ASIC. Let's start out at the highest level, then dig deeper to smaller components. Here I've got a 7-segment display. I'd like a convenient way to drive it. I could connect each of the 7 segments to a drive pin, but that requires a lot of I/O. Instead, what if I can insert a device between the display and my microcontroller, which allows me to drive it with only 4 pins. With 4 binary inputs, we can represent 0 to 15. This is called binary coded decimal. The input device takes that binary number input and drives the display in a way that displays the decimal number we're feeding it. This is the basic BCD decoder. We're going to implement this IC using only transistors, but again, baby steps. We know what we want, so let's define the logic to get there. Let's discuss logic gates, starting with the most simple, the inverter. Digital logic has 2 states, high and low. Low is 0 volts, and high is some voltage above that, typically positive 3.3 or 5 volts. The inverter takes in an input and returns the, well, inverse. Shocking, I know. So if you feed this device a logic low, 0 volts, it spits out a logic high, 5 volts. Similarly, if I feed it a high voltage, it spits out a low voltage. This table is called a truth table and shows the set of outputs for a given set of inputs associated with this gate. Let's now discuss the OR gate. This is slightly more complex than the inverter. It has 2 inputs and 1 output. If any or both of those inputs are high, then the output will be high. In other words, this gate only has a low output if none of the inputs are high. Finally, we have the AND gate. The AND gate also has 2 inputs, but it only outputs a high when both inputs are high. Its truth table looks like this. We can build upon this once more to gates with more than 2 inputs. Draw out the truth table for a 3-input OR gate and a 3-input AND gate now. Their truth tables look like this. For the AND gate, the output is only high if all the inputs are high, and for the OR gate, the output is only low if all of the inputs are low. Great, let's go back to that BCD converter and apply some similar logic. You may have realized that there's also a truth table for the BCD converter. It looks like this. On the left side, we have the binary count common to all segments, and on the right side, we have an output column for each segment, A through G. Let's focus exclusively on segment A for now. Looking at this output, it's pretty obvious that we can't just use a 4-input AND or OR gate here. We need something more complex and combinational. Perhaps some complex combinational logic. We're going to combine a few AND or inverter gates, AOI, together to make a combination to handle the output for segment A. There are numerous ways to do this, but I'm going to jump straight into K-maps. The K-map is another graphical representation of the truth table, which allows us to calculate the logic required for a given input. It all starts with this drawing here. We copy the output of the truth table into this drawing and group like values into boxes sized to powers of 2. This allows us to simplify the inputs, reducing the gate count. We then add or OR the boxes together to achieve the overall expression. For segment A, this is B, not C, not D, ORed with not A, not B, not C, D. You'll then repeat these steps for all 7 segments and come up with this list of expressions. The groups of letters are all ANDed together, and the pluses represent OR gates. We can implement these in a schematic like so. Note that a bar above a letter means it's inverted. Note the placement of the inverters. Since we used inverted B a few times, we can pull the inverter out and just label it as not B. Congratulations, we're through that level and finally down to the transistor. Your typical MOSFET has 3 terminals, a gate, a drain, and a source. Drain and source flip depending on the type of MOSFET, but gate remains the same. Think of a MOSFET as a voltage-controlled switch. Let's focus on N-channel MOSFETs, NMOS, first. For an N-channel MOSFET, the source connects to ground and the drain connects to the load. These guys need to be near the ground. The gate then controls the current flow through the device. If the gate is pulled high, current is allowed to flow. If the gate is pulled low, current is unable to flow. A P-channel MOSFET, PMOS, is similar, but a little flipped. A PMOS needs to be near the voltage. The source connects to the voltage source, and the drain connects to the positive terminal of the load. If the gate is pulled up to the voltage rail, current is unable to flow. Current is able to flow once the gate is pulled down to ground. So let's go back to the inverter. An inverter requires 2 MOSFETs to make, an NMOS and a PMOS in this form. Both inputs are tied together, and the output is tapped at the middle. Now for the AND gate. Let's start with this structure. When both A and B are pulled low, current flows from the voltage source out through the output, making the output high. This already doesn't seem quite right, so let's build a truth table. If either A or B are pulled high, we get the same behavior, so that's a 1 at the output. Finally, if both A and B are pulled high, we inhibit current flowing from the voltage source and allow current to flow to ground. This is a low output. That gives us a truth table, which is conveniently for a NAND gate, an inverted AND gate. So let's take a look at that inverter we just made and stick it on the end of this NAND gate. We now have a proper AND gate. And if you guessed we'd see the same thing for the OR gate, you'd be correct. Here's the full figure. To expand these to 3 or 4 input versions, simply add an extra N and P channel MOSFET. For a little more context, this top section is called the pull-up network. The lower section is called the pull-down network. This is because these networks of transistors either pull up or down the output voltage. With all that done, I created a schematic in KiCad, laid out the necessary MOSFETs to create these gates, then laid out this big thing. KiCad really isn't the correct software for this task. I created an individual PCB for each gate, then appended those files as needed to this central file to create the actual decoder. It's a bit of a mess, but it works. I'll ship this design off to PCBWay to have it fabbed, then come back and test it out when it's done. Our friends at PCBWay graciously sponsored this video, so let's talk about them. PCBWay is a board house that makes high-quality PCBs for your projects or products. They offer tight tolerances, fast turnaround times, and they have fantastic customer support. Since we had these boards assembled by them, their staff reached out to ensure every step of the process was correct, from component ordering to component placement. If you need PCBs for your next project, check out PCBWay. And it doesn't work. Oops. In my initial excitement for this project, I forgot how K-maps worked, and I pulled in my truth tables incorrectly. You may have noticed the discrepancy between the schematic and the shown expressions earlier. That's why. I've confirmed the shown expressions to be correct. One easy way to test these boards is to hook them up to an Arduino. The Arduino provides the BCD count and can also read all 7 outputs of the decoder. This allows me to easily put it in a serial monitor, copy it over to Excel, and do some analysis. Here we can see the good output, and here's my present output. The green columns are identical, and I've highlighted the bad segments yellow with bit discrepancies in red text. You can see this another way when I place the good segment A output next to the schematic. Notice the issue? Stay tuned for a future video where we'll put this board under the knife and attempt to make microscopic repairs to restore full function. Can't do that with silicon. Bye!
And welcome back to this US Open office plan.
Miller just lobbed a message way over Jones's head.
Hi there, I'm Matt Venn, and I've recently learned how to design my own chips. This is something I never expected to be able to do. I've been using microchips for years, but I never thought that one day I'd learn how to do it myself. We've all seen these little computer chips that run our programs, but you've probably never thought about who designed them or how they're made. How exactly do we go from an idea to a computer chip? If you're curious to see how all this fits together, then the Zero to ASIC course is for you. Everything you need to know to go from zero to a custom chip. It's a very hands-on course that you do in your own time. I support you in one-on-one meetings, in the group calls, and on the Discord community server. The first part of the course is looking at the very lowest level, that's the transistors, and how they're built into little functional blocks like AND gates and OR gates. Then we'll be learning about building these small blocks into a larger digital design. This will be covered in a couple of hands-on projects. The first is making an RGB LED color mixer, and the second is making a frequency counter. You're also free to work on your own custom design. We'll cover simulation and verification at this point, checking the design works as intended and proving it doesn't mess up any of the other designs. Then we move on to the open source ASIC flow. This is called OpenLane, and we use it to turn our digital designs into the files we need to send to the chip factory. The last part of the course is looking at the free ASIC shuttle. This is a collaboration between Google, Skywater, and eFabless that opens the door for interested people like us to actually get an ASIC into our own hands. All the designs get put together into one application, and then we send this off to the shuttle program. So far, 14 people on the course have been successful in making an application. If that sounds interesting, then check out the zerotoasiccourse.com website. The full course details are posted there. So sign up today to learn how to go from zero to ASIC with me, Matt Venn. Normally, making a custom chip costs tens of thousands of dollars, and don't forget another $100,000 for renting the design when interested in learning more or getting their designs made into silicon. All our learning resources and tools are free to use, and they're online to avoid download, installation, and licensing problems. If you're a total beginner, you can try Walkway, our digital design and simulator tool. Or, if you know what you're doing, you can use a hardware description language like Verilog, VHDL, or Amaranth. Then, use our GitHub Action-based system to build the files you need for the ASIC. Once the files are ready, you can explore the layout with this really cool 3D viewer. The minimum size is 160 by 100 microns, about 1,000 logic cells. And if you need more space, you can buy extra tiles. Each design gets access to clock, reset, and 24 IOs, with about 50 MHz bandwidth. Tiny Tapeout isn't just for digital designs. For Tiny Tapeout 6, we've added analog and mixed signal support, as well as support for designs made with proprietary tools like Cadence. Once the design is ready, we send it to eFabless, and they'll manufacture it on the open source Skywater 130nm process. The first 100 submissions from individuals will get an early bird discount thanks to eFabless sponsorship. And I want to say a really big thanks to eFabless for sponsoring this project and making it possible. Once we get the silicon back, we save you time and trouble by mounting the chip onto a demonstration board. After plugging the board into your computer, you select which design you want to be active with our MicroPython interface. And that also lets you adjust the clock speed, set the inputs, and monitor the outputs. One of my favourite things about this project is that you're not only going to get your design, but everybody else's design as well. You'll be able to look through the chip's datasheet and try out someone else's design. In our previous runs, we've seen some really interesting designs, including RISC-V CPUs, FPGAs, ring oscillators, synthesizers, USB devices, and loads more. To get started, follow the video tutorials. Expect it to take between a few hours and a few weeks depending on how complex your design is. If you get stuck, join our Discord community chat. Make sure you sign up to the mailing list to keep up to date with our progress. So have fun, get involved, and I'm really looking forward to seeing what you make on your first ASIC.
my goblins and ghouls, my name is Steven. Long time no see, huh? If you're new here, a few years ago I started a project around an open source pick and place machine, and then shortly after that I started a company around selling them. If you want to start the whole saga from the beginning, you can click here to catch up. So the current version of the Lumen is spicy. It's fast, it's pretty easy for us to put together here at Opulo, but in the effort of constantly improving, we're working on a new version. This isn't going to be a huge update, but it is going to fix a couple very specific things that makes it more easy for us to build it here and a little bit easier for people to use. First off, I want to make mounting stuff to the staging plate easier. Right now the staging plate, that big panel that goes across the machine and holds the camera and the bottom light, it's doing double duty. It's not only mounting your strip feeders and your PCB, dude, that looks so good.
It's a major improvement.
And all of the controls are, I mean, it doesn't even need the staging plate. Like the pumps and valves. Here, let's get this sucker open. There we go. Yo, dude, that's so cool looking.
Thank you.
These two lines go out to the head, and then on the other side we have them go to the vacuum sensors on the motherboard, and then on the back side it goes back to the pumps are actually mounted behind the motherboard, and then the valves are right here. So all the pneumatics is just one layer behind, and then the electronics and a little bit of the pneumatics runs out front, and then that front port on the box goes out to the whole head and everything else we need to control. That's so cool. And you can put cable chains on this too.
Yeah, we're trying it out. Hopefully we'll make the final cut. And look at that.
Yeah, that's great. Because right now we have just one that goes from the front left leg. Whoop. Well on our way to the next release. Things went to me a ton. Works the first try. Also, if you have about anything, to make a lot of quick revisions and get new designs out the door quickly. Thank you so much to PCB.
Sand. It's coarse, it's rough, and it can make for a great battery. And as weird as that might sound, it's just one example of the many earthy materials that are currently used for thermal energy storage, or TES. Now, a while back, we covered the debut of a commercial sand battery, which is big enough to supply power for about 10,000 people. But now, sand-based energy storage has reached a new frontier: individual homes. Companies like Bat Sand are currently offering heat batteries that bring hot, fresh sand directly to your door. Seems like you need just about anything delivered these days. But what stopped us from experimenting with residential TES before? How will heat storage impact our lives in our homes? And where exactly are homeowners supposed to put this stuff? I'm Matt Farrell. Welcome to Undecided. Brought a little general power that you that can solar panels, TES is heat, whatever. So long as it can hold onto that heat for a long period of time, we can then discharge and release that heat at a later date through a basic cooling process. Drain this sand tank underground, a DIY. That's your thermal home, heat farm or home, and whether you're a homeowner or that heat back into electricity because a small but significant amount of power is lost in translation. Though statistically speaking, you're already spending most of your power on heating your home, so saving and using that heat later really isn't a problem. This means that TES devices work well in tandem with other energy storage ones like the application. Our energy is exciting on batteries or versatile. The more NES store has a 5,000 to 6,000 euro price tag, which is about $5,300 to $6,400, and it depends on the size. And these figures do include installation, though I worry those numbers will go up once it leaves the pre-order stage. Batsand's smaller 14 kilowatt system will run you a very reasonable 7,200 euros or about $7,700, but with installation, it balloons to a hefty 17,000 euros or $19,000 on the low end. That kind of price point means these devices aren't going to fit into a lot of energy, and because TES devices are only as green as the energy that we put into them. Take water heaters, for example. As recently as 2010, a typical resistance electric water heater produced.
Good evening, Thrill Team. Tonight, you're third wheeling on a second date.
Chemistry is looking good. Cardigan compliment.
This video is brought to you by Brilliant. What do you do if as a result many satellites use very efficient, reliable, and long-lived nickel hydrogen batteries? We're talking about batteries that may last decades. That sounds like the sort of battery that could revolutionize grid-scale energy storage and really it's no slow tools. The chemistry and engineers these batteries, and it could revolutionize renewable energy and grid-scale energy storage. The unique chemistry and engineering of these batteries can allow them to retain 86% of their capacity after 30,000 cycles, or roughly 30 years, with zero maintenance to boot. Better yet, these batteries are extremely temperature tolerant, so it's no slouch on power either. And like other battery suit your has base, the battery was passed to naval research. Batteries have been popular. Met top of this intervention is ready, by the way, 250% in 2022. Live battery means less batteries that get thrown away or need cost-effective gas designed for spy satellites and deep space probes. Nickel hydrogen batteries are very expensive devices. The cost is so intense, it's the main reason we haven't seen this tech on Earth very much. It's been a financial limiting factor, not a technological one. And despite possible cost savings from the lack of maintenance, the commonality of nickel and other features, These batteries prominently feature pricey platinum or palladium. If you've ever been unfortunate enough to have your catalytic converter stolen, you're probably all too familiar with how expensive these metals are. We don't have to give up on these incredible batteries yet though, because Enervenue believes it's found a way to make nickel hydrogen not just cheaper, but even cost competitive with the market dominated to form large-scale storage plants as Enervenue claims. Similarly, utility companies are often change-averse, and for a good reason. As long as you have the time to take a course, but Brilliant is built around bite-sized lessons to break down concepts. Maybe. There's still plenty of known unknowns, like whether developers can successfully hook up these funky batteries to form large-scale storage plants as Enervenue claims. Similarly, utility companies are often change-averse, and for a good reason. As long as the power is flowing, their customers are happy. But anything that threatens that state of order could lead to big trouble. Are these companies ready to adopt something so out of the ordinary, even a long-proven piece of space technology? Remains to be seen. But if these batteries work as advertised and the utilities do adopt them, then the biggest albatross around the neck of renewables
we give you access to more than 1,600 milling and turning machines locally and globally. You can choose from more than 60 production-grade machines.
Hi guys, welcome to another Learn Electronics Repair video. This, it was about 8 or 9 of us working in the workshop, and we were getting PCBs brought in by the sales reps from industrial equipment, and we would just get the PCB like this and ask, can you fix it please? And that'd be it, can you fix it? You've got this. It came off some bit of unknown machine, and that's what you have. It could have come off. I mean, I remember getting circuit boards that I knew came off overhead trains. Occasionally went out on site. Another one was from a machine that effectively was a company who made Formula 1 engines and developed down in Coventry, and they were using a machine that effectively measured the cam on the camshaft, the size of the cams as it rotated, the angular rotation and size, and I had PCBs from that machine. So I have all sorts of things to fix. This one actually is a little bit more down to earth. It comes off a coffee machine. And Handy Andy from the phone shop brought this, and he'll bring me anything these days. Rich, can you check that out? Can you fix gate? So this is 39k, 39k, 39k. Gate. Here we go.
What is an FPGA? My name is Grady, I'm with Simply Embedded, and today I'm going to talk about the basics of FPGAs. So let's get started. Sections below, and let's begin with the concept. FPGA stands for Field Programmable Gate Array. That is an integrated circuit designed to be reprogrammable using hardware description language, such as Verilog HDL or VHDL. The fact that FPGAs are reprogrammable distinguishes FPGAs from application-specific integrated circuits, also known as ASICs, which are integrated circuits manufactured to do specific designed tasks. Although they're one-time programmable FPGAs, the dominant types are reprogrammable FPGAs. Let's look at this example. You created a logic design, and after downloading the design to an FPGA, you notice that you made a mistake. Well, since you have an FPGA, this won't be a problem. You can go ahead and change the design by rewriting new hardware code for it, and reprogram your new design to FPGA. Whereas if after manufacturing the ASIC, you notice a mistake in the design, you can't just change the design on that specific chip. You need to remanufacture a completely new one. An FPGA is typically based on a matrix of configurable logic blocks, also known as CLBs. CLBs are made out of 4 basic components: lookup tables, multiplexers, full adder, and D flip-flop. Reconfigurable interconnects. These allow CLBs to be connected with one another. Input-output blocks. They facilitate external connections for the FPGA. They carry signals into or out of the FPGA. Fixed function logic blocks, such as multiplier or digital signal processing blocks. And block RAM. Block RAM serves as a large memory structure or a group of flip-flops tied together. Some advantages to an FPGA in today's market are performance, such as faster and parallel processing of signals,
which is hard to do for processors because they're typically sequential. Reprogrammable hardware
We've all seen these little computer chips that are inside all our gadgets, but probably you've never really thought about who designed them and how they're made. How exactly do we turn an idea into a microchip? If you're curious to see how all this fits together, then the Zero to ASIC course is for you. Everything you need to know to go from zero to a custom chip with open source tools. Over the last 3 years, I've helped people like you send over 300 designs to get manufactured. The wait times are fairly long, but we've now received chips back from the first 3 shuttles. I've tested the designs we use in the course, and I've even got my own clock running right here on my desk. How cool is that?
This is probably the best course you can get your hands on for practical stuff.
Amazing course.
It's a very hands-on course, split into 11 projects that you do in your own time. The first part of the course is looking at the very lowest level, that's the transistors, and how they're built into little functional blocks like AND gates and flip-flops. Then, you'll be learning about building these small blocks into a larger digital design using the Verilog hardware description language. This will be covered in a couple of hands-on projects. The first is making an RGB LED color mixer, and the second is making a frequency counter. You'll also be free to work on your own custom design. We'll cover simulation and verification at this point, checking the design works as intended and proving that it doesn't mess up any of the other designs. Then we move on to the open source ASIC flow. This is called OpenLane, and we use it to turn our digital designs into the files we need to send to the factory. The last part of the course covers the options we have to get your design actually manufactured. The Google-sponsored open source lottery shuttles, the eFabless Chip Ignite service, and Tiny Tapeout. During the course, you'll get support from the course community Discord server, weekly group calls, and one-to-one office hours with me.
Lots of awesome help on the Discord.
There's a lot of cool things, and people are so awesome and they're really helpful.
Some interesting designs submitted by course participants include cryptography accelerators, EMFI glitch detectors, Conway's Game of Life, and spiking neural networks. If you want to learn more, then check out the zerotoasiccourse.com website and sign up to the mailing list. The full course structure is posted there. So sign up today and learn how to go from zero to ASIC with me, Matt Venn. Ching!
Take the course, it's good, you want it.
Is simple,
excellent,
and environmentally friendly. The city of
Yes, it's so exciting to get my first chips back and actually see some life out of them. Here you can see one of my super simple designs actually working in silicon. Full disclosure, due to the issues in MPW1, I'm unable to enable all segments at once, so I made this video by compositing with 2 different sets of IOs.
Now move back to a more sort of technical role where, yeah, I have the nice title of being the IC scientist.
Yeah, it's a cool job title. And for me, it's really interesting because you're obviously very high up in the industry, and you're also really interested in the idea of open source semiconductors. So that's... Hi, and I've got a question for you. What do you get if you cross a snowy holiday with the principal chip scientist at Nordic Semiconductor? an A to D taped out on Tiny Tape Out by Karsten. Hi, Karsten. How's it going?
Hi, how's it going? It's going good.
Yeah, great to see you in an interview call. Normally used to seeing you on the YouTube channel.
Yeah.
Tell us briefly about the story of your snowy holiday.
Right, so it actually started right before the holiday. So I got to learn that on the Tiny Tape Out 6, there was the option of doing analog. And then we got in touch somehow through YouTube, LinkedIn, something. And you mentioned if I had any sort of designs ready. And I first thought, no, that's way too much work. I don't have time for that. But then I had holiday. We have a concept called winter holiday here in Norway. So I went up to the mountains with my kids and brought my computer and actually had some time to code on my SAR. So this is a design that I had from, well, way back when. And actually, I guess last Friday, I was able to complete it and then submit it. And yeah, a really fun story.
Yeah. So you've already done a video about an hour long, really going into the details of the SAR, and it's a fascinating watch. And there's a paper as well. So if you're interested to find out all the gory details, then check out the video, which I'll link above somewhere. And on this video, I wanted to more kind of get to know you a bit as a person and ask you some difficult questions.
Good.
So I hope you're ready. And yeah, looking through your CV, which you posted online, it's amazing to be talking to the principal IC scientist for Nordic Semi. Yeah.
Well, thank you.
Yeah. And you're kind of been involved in the NR51 series analog design and all of that.
Yes. So I started in Nordic 15 years ago, right after my PhD. So I usually say it's my first and only real job is in Nordic Semiconductor.
Yeah.
So most of the time been working on analog design, but then I led the wireless group for about 7 years. But then now moved back to a more sort of technical role where, I have the nice title of being the IC scientist.
Yeah, it's a cool job title. And for me, it's really interesting because you're obviously very high up in the industry. And you're also really interested in the idea of open source semiconductors. So that's really what I wanted to talk to you about. So yeah, why open source?
So I guess it started, I should also mention that I teach at the Norwegian University of Science and Technology. So I'm there 20%, 1 day a week, teaching a course on advanced integrated circuits. And that's really because we see from Nordic side that we need more analog designers. Over time, we need them to be educated, and that's sort of why I've joined in at NTNU. And when I saw, I think this was 2021 probably, when I discovered the SkyWater PDK. And I've been looking for that type of opportunity because I've been working on closed source type of, or closed NDA type of PDKs for a long time. But my interest really lies in how do we make analog circuits? How do we simplify that? And that's quite hard when you only work on closed source PDKs and also on binary files. So the fact that now there was this open source PDK, there was the Magic tool, which I love the fact that it's text files. There was XGEM, which is also text files. That enabled me to actually port the work that I've already been doing for about 10 years over to SkyWater and really get going and sort of go all in. And I think it's an interesting ride.
Yeah. Maybe this is a good point to ask you how the professional tools compare.
So I have an S5 and I flashed it with Bitmain's firmware, this one specifically. As you see, they have three here, 1, 2, 3. The file's truncated. I've notified them of it. They haven't updated it yet. And they have the MD5 sums here. So as you can see, that one doesn't work. I've already copied this one here, and that one's good. So this MD5 sum's not good for this file. That's how you check that. So what you have to do is go down here to their flashing SD card with image. Anyways, I already have that here. Extract it. You have to do this on Windows. Open this, you load the image, and you flash it to a micro SD card. And you pop that into your S5, turn it on, wait a couple minutes, power it off, and power it back on. It should have flashed new firmware in there, and it flashes it as an S3. So you'll need to go back and through here again, flash it with one of the other two newer firmwares, and that should fix your problem.
Are you looking for server systems powered by AMD EPYC's 9004 processors to build out your next generation infrastructure? Did you know there's a faster, easier way
Hi everyone. Thanks for coming to session on WebRTC or WebRTC at Google. And with me today is, hey, has anyone seen Sam? Hey, Sam Dutton coming to you live from WebRTC on Chrome for Android.
On a beautiful Nexus 7. We got this low res to cope with the Wi-Fi here, but it seems to be working pretty well.
That was quite an entrance. Why don't you come up here and introduce yourself?
Yeah. Hey, I'm Sam Dutton. I'm a developer advocate for Chrome.
So we're here to talk to you today about the great things that WebRTC has been working on and how you can use them. So what is WebRTC? Well, in a nutshell, it's what we call real-time communication, RTC. The ability to communicate live with somebody or something as if you were right there next to them. And this can mean audio, video, or even just peer-to-peer data. And we think WebRTC is really cool. But there's a lot of other people who are really excited about WebRTC as well. And one of the reasons is that WebRTC fills a critical gap in the web platform. Where previously a native proprietary app like Skype could do something the web just couldn't. But now we've turned that around and changed it so we have a web of connected WebRTC devices that can communicate in real time just by loading a web page. So here's what we're trying to do with WebRTC. To build the key APIs for real-time communication into the web. To make an amazing media stack in Chrome so the developers can build great experiences. And to use this network of connected WebRTC devices to create a new communications ecosystem. And these kind of seem like lofty goals. But take this quote from the current CTO of the FCC, who said he sees traditional telephony fading away as voice just becomes another web app. So we're trying to live up to that promise. And right now, you can build a single app with WebRTC that connects Chrome, Chrome for Android, Firefox, and very soon, Opera. I'm especially excited to announce that as of this week, Firefox 22 has gone to beta, which is the very first WebRTC-enabled version of Firefox. So within a matter of weeks, we will have over 1 billion users using a WebRTC-enabled browser. And I think that just kind of gives like a good idea of the size of the opportunity here. And we expect that number to grow very significantly as both Chrome and Firefox get increased adoption. For places where we don't have WebRTC-enabled browsers, we're providing native, supported, official toolkits on both Android and very soon iOS that completely can interoperate with WebRTC in the browser. So here are just a handful of the companies that see the opportunity in WebRTC and are building their business around it. So that's the vision for WebRTC. Now let's dig into the APIs. There are three main categories of API that exist in WebRTC. First, getting access to input devices. Accessing the microphone, accessing the webcam, getting a stream of media from either of them. Secondly, being able to connect to another WebRTC endpoint across the internet and to send this audio and video in real time. And third, the ability to do this not just for audio and video, but for arbitrary application data. And we think this one is especially interesting. So because of three categories, we have three primary objects in WebRTC to access this stuff. The first one, media stream, is for getting access to media, then RTC peer connection, and RTC data channel. And we'll get into each one of these individually. Sam, why don't you tell us about media streams?
Yeah, sure. So media stream represents like a single source of synchronized audio or video or both. Each media stream contains one or more media stream tracks. For example, on your laptop, you've got a webcam and a microphone providing video and audio streams, and they're synchronized. we get access to these local devices using the get user media method of Navigator. So we just look at the code for that, just highlight that. And you can see that get user media there, it takes 3 parameters, 3 arguments there. And the first one, if we look at the constraints argument I got, you can see I'm just specifying I want video. That's all I'm saying. Just give me video, nothing else. And then in the success callback, we're setting the source of a video using the stream that's returned by get user media. Let's see that in action. Really simple example here. And you can see when we fire the get user media method, we get the allow permissions bar at the top there. Now this means that users have to explicitly opt in to allowing access to their microphone and camera. And yeah, there we have it. Using that code, we've got video displayed in a video element. Great. What really excites me about these APIs, is when they kind of come up against each other. Like in this example, what's happening is that we've got get user media being piped into a canvas element, and then the canvas element being analyzed and then producing ASCII, just like that. Which could make a good codec, I think.
Yeah, that'd be a good codec. You can compress it using just gzip.
Yeah, like smaller font sizes, higher resolution.
Yeah.
Also, another example of this from FaceCat. Now, what's happening here is that it's using the head tracker JavaScript library to track the position of my head. And when I move around, you can see I'm moving through the game and trying to stay alive, which is quite difficult. God, this is painful. Anyway, whoa. Okay, I think I've flipped into hyperspace there. And an old favorite you may well have seen, Webcam Toy, which gives us access to the camera, kind of photo booth app, uses WebGL to create a bunch of slightly psychedelic effects there. Quite like this old movie one, so I'll take that and yeah, get a snapshot. And I can share that with my friends. So beautiful work from Paul Neve there. Now, you might remember I said that we can use the constraints object. The simple example there was just saying, use the video, nothing else. Well, we can do more interesting things with constraints than that. We can do stuff like specify the resolution or the frame rate, a whole stack of things that we want from our local devices. A little example from that. If we go over here, now let's look at the code actually. If we go to the dev tools there, you can see that I've got 3 different constraints objects, one for each resolution.
Hi everyone. Thanks for coming to a session on WebRTC for plugin-free real-time communication. I'm Justin Uberti, tech lead for WebRTC at Google. And with me today is, hey, has anyone seen Sam?
Hey,
Sam Dutton coming to you live from WebRTC on Chrome for Android.
On a beautiful Nexus 7. We got this slow res to cope with the Wi-Fi here, but it seems to be working pretty well.
That was quite an entrance. Why don't you come up here and introduce yourself?
Yeah. Hey, I'm Sam Dutton. I'm a developer advocate for Chrome.
So we're here to talk to you today about the great things that WebRTC has been working on and how you can use them. So what is WebRTC? Well, in a nutshell, it's what we call real-time communication, RTC. The ability to communicate live with somebody or something as if you were right there next to them. And this can mean audio, video, or even just peer-to-peer data. And we think WebRTC is really cool. But there's a lot of other people who are really excited about WebRTC as well. And one of the reasons is that WebRTC fills a critical gap in the web platform. Where previously a native proprietary app like Skype could do something the web just couldn't. But now we've turned that around and changed it so we have a web of connected WebRTC devices that can communicate in real time just by loading a web page. So here's what we're trying to do with WebRTC. To build the key APIs for real-time communication into the web. to make an amazing media stack in Chrome so the developers can build great experiences, and to use this network of connected WebRTC devices to create a new communications ecosystem. And these kind of seem like lofty goals, but take this quote from the current CTO of the FCC, who said he sees traditional telephony fading away as voice just becomes another web app. So we're trying to live up to that promise. And right now, you can build a single app with WebRTC that connects Chrome, Chrome for Android, Firefox, and very soon, Opera. I'm especially excited to announce that as of this week, Firefox 22 has gone to beta, which is the very first WebRTC-enabled version of Firefox. So within a matter of weeks, we will have over 1 billion users using a WebRTC-enabled browser. And I think that just kind of gives like a good idea of the size of the opportunity here. And we expect that number to grow very significantly as both Chrome and Firefox get increased adoption. For places where we don't have WebRTC-enabled browsers, we're providing native, supported, official toolkits on both Android and very soon iOS that completely can interoperate with WebRTC in the browser. So here are just a handful of the companies that see the opportunity in WebRTC and are building their business around it. So that's the vision for WebRTC. Now let's dig into the APIs. There are three main categories of API that exist in WebRTC. First, getting access to input devices. Accessing the microphone, accessing the webcam, getting a stream of media from either of them. Secondly, being able to connect to another WebRTC endpoint across the internet and to send this audio and video in real time. And third, the ability to do this not just for audio and video, but for arbitrary application data. And we think this one is especially interesting. So because of three categories, we have three primary objects in WebRTC to access this stuff. The first one, media stream, is for getting access to media, then RTC peer connection, and RTC data channel. And we'll get into each one of these individually. Sam, why don't you tell us about media streams?
Yeah, sure. So media stream represents like a single source of synchronized audio or video or both. Each media stream contains one or more media stream tracks. For example, on your laptop, you've got a webcam and a microphone providing video and audio streams, and they're synchronized. We get access to these local devices using the get user media method of Navigator. So we just look at the code for that, just highlight that. And you can see that get user media there, it takes three parameters, three arguments there. And the first one, if we look at the constraints argument I got, you can see I'm just specifying I want video. That's all I'm saying. Just give me video, nothing else. And then in the success callback, we're setting the source of a video using the stream that's returned by get user media. Let's see that in action. Really simple example here. And you can see when we fire the get user media method, we get the allow permissions bar at the top there. Now this means that users have to explicitly opt in to allowing access to their microphone and camera. And yeah, there we have it. Using that code, we've got video displayed in a video element. Great. What really excites me about these APIs, is when they kind of come up against each other. Like in this example, what's happening is that we've got get user media being piped into a canvas element, and then the canvas element being analyzed and then producing ASCII, just like that. Which could make a good codec, I think.
Yeah, that'd be a good codec. You can compress it using just gzip.
Yeah, like smaller font sizes, high resolution.
Yeah.
Also, another example of this from FaceCat. Now, what's happening here is that it's using the head tracker JavaScript library to track the position of my head. And when I move around, you can see I'm moving through the game and trying to stay alive, which is quite difficult. God, this is painful. Anyway, whoa. Okay, I think I've flipped into hyperspace there. And an old favorite you may well have seen, webcam toy, which gives us access to the camera, kind of photo booth app, uses WebGL to create a bunch of slightly psychedelic effects there. Quite like this old movie one, so I'll take that and yeah, get a snapshot. And I can share that with my friends. So beautiful work from Paul Neve there. Now, you might remember I said that we can use the constraints object. The simple example there was just saying, you know, use the video, nothing else. Well, we can do more interesting things with constraints than that. We can do stuff like specify the resolution or the frame rate, a whole stack of things that we want from our local devices. A little example from that. If we go over here, now let's look at the code actually. If we go to the dev tools there, you can see that I've got 3 different constraints objects, one for each resolution. So when I press the buttons, I use the QVGA constraints, get user media, and then with the VGA one, I'm getting higher resolution, and for HD, I'm getting the full 1280 by 720. We can also use get user media now for input from our microphone. In other words, we can use get user media to provide a source node for web audio. And there's a huge amount of interesting stuff we can do with that, processing audio using web audio from the mic or wherever. Little example of that here. Just allow access to the mic, and you can see I'm getting a nice little visualization there in the canvas element. And I can start to record this, blah, 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 blah. And then record this, blah, 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 blah. And yeah, you can see that's used recorder.js to save that locally to disk. Get user media also now, this is kind of experimental, but we can use get user media to get screen capture. In other words, data coming directly from what we see on screen, not from the audio video from the mic and the camera. Probably the simplest if I show an example of this. So yeah, a little application here, and when I click to make the call, allow, and you can see there that I get this kind of crazy hall of mirrors effect because, you know, I'm capturing the screen that I'm capturing and so on and so on. Now that's quite nice, but it would be really useful if we could take that screen capture and then, you know, transmit that to another computer. And for that, we have RTC peer connection.
Thanks, Sam. So, as the name implies, RTC peer connection is all about making a connection to another peer. And over this peer connection, we can actually then go and send audio and video. And the way we do this is we take the media streams that we've gotten from Get User Media, and we plug them into the peer connection and send them off to the other side. When the other side receives them, they'll pop out as a new media stream on their peer connection, and they can then plug that into a video element to display it on the page. And so both sides have a peer connection. They both get streams from Get User Media. They plug them in, and then those media streams pop out, magically encoded and decoded on the other side. Now, under the hood, peer connection is doing a ton of stuff. Signal processing to remove noise from audio and video. Codec selection and compression and decompression of the actual audio and video. Finding the actual peer-to-peer route through firewalls, through NATs, through relays. Encrypting the data so that the user's data is fully protected at all times. And then actually managing the bandwidth so that if you have 2 megabits, we use it. If you have 200 kilobits, that's all we use. But we do everything we can to hide this complexity from that web developer. And so the main thing is that you get your media streams, you plug them in via add stream to peer connection, and off you go. And here's a little example of this.
Yeah, so you can see here that we've created a new RTC peer connection, and then when the stream is received, the callback for that in got remote stream there attaches the media we're getting from a video element to the stream. Now, at the same time, we're also creating what's called an offer, giving information about media, and we're setting that as the local description and then sending that to the callee so that they can set the remote description. You can see that in the got answer function there. Let's have a little look at RTC peer connection on one page. A really simple example here. So what we've got here is, we'll get user media here, just start that up. So it's getting video from the local camera here, displaying it in the left there. Now, when I press call, it's using RTC peer connection to communicate that video to the other video element on the page there. This is a great place to start to get your head around RTC peer connection. And if we look in the code there, you can see that, you know, it's really simple. There's not a lot of code there to do that, to transmit video from one peer to another.
So that's really cool stuff. You know, a full video chat client in a single web page and just about 50 lines of JavaScript. And we talked a little bit quickly through the whole thing around how we set up the parameters of the call, the offers and answers, but I'll come back to that later. The next thing I want to talk about is RTC data channel. And this says if we have a peer connection, which already creates our peer-to-peer link for us, can we send arbitrary application data over it? And this is the mechanism that we use to do so. Now, one example where we would do this would be in a game. Like take this game, I think it's called Jank Wars or something, and we have all these ships floating around on the screen. Now, when a ship moves, we want to make sure that's communicated to the other player as quickly as possible. And so we have this little JSON object that contains the parameters and the position and the velocity of the ships. And we can just take that object and stuff it into the send method, and it'll shoot it across the other side where it pops out as on message. And the other side can do the same thing. It can call send on its data channel, and it works pretty much just like a WebSocket. That's not an accident. You know, we tried to design it that way so that people familiar with using WebSockets could also use a similar API for RTC data channel. And the benefit is that here we have a peer-to-peer connection for the lowest possible latency for doing this communication. In addition, RTC data channel can be either unreliable or reliable. And we can think about this kind of like UDP versus TCP. If you're doing a game, it's more important that your packets get there quickly than they're guaranteed to get there. Whereas if you're doing a file transfer, the files are only any good if the entire file is delivered. So you can choose this as the app developer, which mode you want to use, either unreliable or reliable. And lastly, everything is fully secure. We use standard DTLS encryption to make sure that the packets you send across the data channel are fully encrypted on their way to the destination. And you can do this either with audio and video, or if you want to make a pure connection for just data, you can do that as well. So Sam's going to show us how this actually works.
Yeah, so again, another really simple example. We're creating a peer connection here, and once the data channel is received, in the callback to that, we're setting the receive channel using the event.channel object. Now, when the receive channel gets a message, kind of like WebSocket really, we're just putting some text in a local div there using event.data. Now, the send channel is created with create data channel, and then we've got a send button, and when that's clicked, we get the data from a text area, and we use the send channel to send that to the other peer. Again, let's see this in action. This is, again, a good place to start, one-page demo with all the code for RTC data channel. So type in some text, and we hit send, and it's transmitting it to the other text area. But a great place to start if you're looking at RTC data channel. Something a little more useful here, a great app from ShareFest. Now, ShareFest is using RTC data channel to enable us to do file sharing. I'm going to select a nice photo here I've got of some cherries, and it's Popeye is the URL. Now, Justin is going to try and get that up on screen on his side just to check that that's gone through. So like I say, this is doing file sharing using RTC data channel, and there's a huge amount of potential there. There we go. There's the cherries. Good. These are beautiful Mountain View cherries, actually. They were really, really nice.
And so all this data is being sent peer-to-peer, and anybody else who connects to the same URL will download that data peer-to-peer from Sam's machine. And so none of this has to touch ShareFest servers. And I think that's pretty interesting if you think about things like file transfer or bulk video distribution. Okay, so we talked a lot about how we can do really clever peer-to-peer stuff with RTC peer connection. But it turns out we need servers to kind of get the process kicked off. And the first part of it is actually making sure that both sides can agree to actually conduct the session. And this is the process that we call signaling. The signaling in WebRTC is abstract, which means that there's no fully defined protocol of exactly how do you do it. The key part is that you just have to exchange session description objects. And if you think about this kind of like a telephone call, when you make a call to someone, the telephone network sends a message to the person you're calling, telling them there's an incoming call and the phone should ring. Then when they answer the call, they send a message back that says the call is now active. Now these messages also contain parameters around like what media format to use, where the person is on the network. And the same is true for WebRTC. And these things, these session description objects contain parameters like what codecs to use, what security keys to use, the network information for setting up the peer-to-peer route. And the only important thing is that you just send it from your side to the other side and vice versa. You can use any mechanism you want, WebSockets, Google Cloud Messaging, XHR, and you can use any protocol. You can just send it as JSON, or you can use a standard protocol like SIP or XMPP. And here's a picture of how this all works. The app gets a session description from the browser and sends it across to the cloud to the other side. Once it gets the message back from the other side with the other side's session description, and both session descriptions are passed down to WebRTC in the browser, WebRTC can then set up and conduct the media link peer-to-peer. So we do a lot of the media link peer-to-peer. And the app PP call. You can use WebSockets for setting up this has to touch ShareFest servers. Peer-to-peer.
These are beautiful Mountain View cherries, actually. They were left on screen on his side just to check that that's gone through. So like I say, this is doing file sharing using RTC data channel, and there's a huge amount of potential there. There we go. There's the cherries. Good. These are beautiful Mountain View cherries, actually. They were really, really nice.
And so all this data is being sent peer-to-peer, and anybody else who connects to the same URL will download that data peer-to-peer from Sam's machine. And so none of this has to touch ShareFest servers. And I think that's pretty interesting if you think about things like file transfer or bulk video distribution. Okay, so we talked a lot about how we can do really clever peer-to-peer stuff with RTC peer connection. But it turns out we need servers to kind of get the process kicked off. And the first part of it is actually making sure that both sides can agree to actually conduct the session. And this is the process that we call signaling. The signaling in WebRTC is abstract, which means that there's no fully defined protocol exactly how do you do it. The key part is that you just have to exchange session description objects. And if you think about this kind of like a telephone call, when you make a call to someone, the telephone network sends a message to the person you're calling telling them there's an incoming call and the phone should ring. Then when they answer the call, they send a message back that says the call is now active. Now these messages also contain parameters around like what media format to use, where the person is on the network. And the same is true for WebRTC. And these things, these session description objects contain parameters like what codecs to use, what security keys to use, the network information for setting up the peer-to-peer route. And the only important thing is that you just send it from your side to the other side and vice versa. You can use any mechanism you want, WebSockets, Google Cloud Messaging, XHR, and you can use any protocol. You can just send it as JSON, or you can use a standard protocol like SIP or XMPP. And here's a picture of how this all works. The app gets a session description from the browser and sends it across to the cloud to the other side. Once it gets the message back from the other side with the other side's session description, and both session descriptions are passed down to WebRTC in the browser, WebRTC can then set up and conduct the media link peer-to-peer. So we do a lot to try to hide the details of what's inside the RTC session description, because this includes a whole bunch of parameters, as I said, codecs, network information, all sorts of stuff. This is just a snippet of what's contained inside a session description right now. Really advanced apps can do complex behaviors by modifying this, but we've designed the API so that regular apps just don't have to think about it. The other thing that we need servers for is to actually get the peer-to-peer session fully routed. And in the old days, this wouldn't be a problem. A long time ago, each side had a public IP address. They send each other's IP address to each other through the cloud, and we make the link directly between the peers. Well, in the age of NAT, things are more complicated. NATs hand out what's called a private IP address, and these IP addresses are not useful for communication. There's no way we can make the link actually peer-to-peer unless we have public address. So this is where we bring a technology called stun. The stun server we contact from WebRTC, and we say, what's my public IP address? And basically the request comes into the stun server, it sees the address that request came from, puts that address into the packet, and sends it back. So now WebRTC knows its public IP address. And the stun server doesn't have to be in the party anymore. It doesn't have to have media flow through it. So here, if we look at this example, each side has contacted its stun server to find out what its public IP address is. And then it's sent the traffic to that other IP address through its NAT, and the data still flows peer-to-peer. So this is kind of magic stuff, and it usually works. Usually we can make sure that the data all flows properly peer-to-peer, but not in every case. And for that, we have a technology called Turn built into WebRTC. This turns things around and provides a cloud fallback when a peer-to-peer link isn't possible. You basically ask for a relay in the cloud saying, give me a public address. And because this public address is in the cloud, anybody can contact it, which means the call always sets up, even if you're behind a restrictive NAT or even behind a proxy. The downside is that since the data actually is being relayed through the server, there is an operational cost to it, but it does mean the call works in almost all environments. Now, on one hand, we have stun, which is super cheap, but doesn't always work, and we have turn, which always works but has some cost to it. How do we make sure we get the best of both worlds? Here's turn in action, where we tried to use stun, and stun didn't work. That we couldn't get the things to actually penetrate the NATs. So instead we fell back, and only then did we use turn, and sent the media from our one peer through the NAT, through the turn server, and to the other side. And this is all done by a technology called ICE. ICE knows about stun and turn, and tries all the things in parallel to figure out the best path for the call. If it can do stun, it does stun. If it can do turn, well then it'll fall back to turn, but it'll do so quickly. And we have stats from a deployed WebRTC application that says 86% of the time we can make things work with just stun. So only 1 out of 7 calls actually have to run through a turn server. So how do you deploy turn for your application? Well, we have some testing servers, a testing stun server that you can use, plus we make source code available for our own stun and turn server as part of the WebRTC code package. But the thing I would really recommend is the long name but really good product, RFC5766 Turn Server, which has Amazon VM images that you can just take, download, and deploy into the cloud, and you've got your turn server provision for all your users right there. You can also recommend ReStunD, another turn server that we've used with excellent results. One question that comes up around WebRTC is, how is security handled? And the great thing is that security has been built into WebRTC from the very beginning. And so this means several different things. It means we have mandatory encryption for both media and data. So all the data that's being sent by WebRTC is being encrypted using standard AES encryption. We also have secure UI, meaning the user's camera and microphone can only be accessed if they've explicitly opted in to making that functionality available. And last, WebRTC runs inside the Chrome sandbox. So even if somebody tries to attack WebRTC inside of Chrome, the browser and the user will be fully protected. So here's what you need to do to take advantage of this security in WebRTC. It's really simple. Your app just needs to use HTTPS for actually doing the signaling. As long as the signaling goes over a secure conduit, the data will be fully secured as well using the standard protocols of SRTP for media or datagram TLS for the data channel. One more question that comes up is around making a multi-party call, a conference call. how should I architect my application? In the simple two-party case, it's easy. We just have a peer-to-peer link. But as we start adding more peers into the mix, things get a bit more complicated. And one approach that people use is a mesh, where basically every peer connects to every other peer. And this is really simple because there's no servers or anything involved, other than the signaling stuff. But every peer has to send a copy of its data to every other peer. So this has a corresponding CPU and bandwidth cost. So depending on the media you're trying to send, for audio it can be kind of higher, for video it's going to be less. The number of peers you can support in this topology, is fairly limited, especially if one of the peers is on a mobile device. To deal with that, another architecture that can be used is the star architecture. And here you can pick the most capable device to be what we call the focus for the call. And the focus is the part that's actually responsible for taking the data and sending a copy to each of the other endpoints. But as we get to handling multiple HD video streams, the job for a focus becomes pretty difficult. And so for the most robust conferencing architecture, we recommend an MCU, or multi-point control unit. And this is a server that's custom made for relaying large amounts of audio and video. And it can do various things. It can do selective stream forwarding. It can actually mix the audio or video data. It can also do things like recording. And so if one peer drops out, it doesn't interrupt the whole conference because the MCU is taking care of everything. So WebRTC is made with standards in mind. And so you can connect to things that aren't even WebRTC devices. And one thing that people might want to talk to from WebRTC is phones. And there's a bunch of easy things that can be dropped into your web page to make this happen. There's a SIP ML5, which is a way to talk to various standard SIP devices, Phono, and what we're going to show you now, a widget from Zingaya to make a phone call.
Okay, so we've got a special guest joining us a little bit later in the presentation. I just wanted to give him a call to see if he's available. So let's use the Zingaya WebRTC phone app now. And you can see it's asking for access on my microphone. Calling someone. I hope it's the person I want. Let's see if he's there.
Hello.
Hey, is that you, Chris?
Hey, Sam, how's it going?
Hey, fantastic. I just want to check you're ready for your gig later on.
I'm ready whenever you are.
That's fantastic. Okay, speak to you soon, Chris. Thanks. Bye-bye.
Talk to you soon. Bye.
Cheers.
It's great. No plugins, real-time communication.
Yeah, that situation, we had a guy with a telephone. Something we were thinking about is situations where there is no telephone network. Now, Voxio demonstrated this with something called Tether, which is kind of disaster communications in a box. Uses the open BTS cell framework. You can see it's that little box there to enable calls between feature phones via the open BTS cell through WebRTC to computers. You can imagine this is kind of fun to get a license for this in downtown San Francisco, but this is incredibly useful in situations where there is no infrastructure. This is like telephony without a carrier, which is amazing.
So we have a code lab this afternoon that I hope you can come to, where we'll really go into the details of exactly how to build a WebRTC application. But now we're going to talk about some resources that I think are really useful. The first one is something called WebRTC internals. And this is a page you can open up just by going to this URL while you're in a WebRTC call. And it'll show all sorts of great statistics about what's actually happening inside your call. This will be things like packet loss, bandwidth, video resolution and sizes. And there's also a full log of all the calls made to the WebRTC API that you can download and export. So if a customer is reporting problems with their call, you can easily get this debugging information from them. Another thing is the WebRTC spec has been updating fairly rapidly. And so in a given browser, the API might not always match the latest spec. Well, Adapter.js is something that's there to insulate the web developer from the differences between browsers and the differences between versions. And so we make sure that Adapter.js always implements the latest spec, and thunks down to whatever the version supports. So as new APIs are added, we polyfill them to make sure that you don't have to write custom version code or custom browser code for each browser. And we use this in our own applications.
Okay, if all this is too much for you, the good news is we've got some fantastic JavaScript frameworks come up in the last few months. Really great abstraction libraries to make it really, really simple to build WebRTC apps just with a few lines of code. Example here from Simple WebRTC. A little bit of JavaScript there to specify a video element that represents local video and one that represents the remote video stream coming in. And then join a room just by calling the join room method with a room name. It's really, really simple. Peer.js does something similar for RTC data channel. Create a peer, and then on connection, you can send messages and receive messages. So really, really easy to use.
So JavaScript frameworks go a long way, but they don't cover the production aspects of the service, the signaling, the stun and turn service we talked about. But fortunately, we have things from both OpenTalk and VLine that are basically turnkey WebRTC services. They handle all this stuff for you. You basically sign up for the service, get an API key, and then you can make calls using their production infrastructure, which is spread throughout the entire globe. They also make UI widgets that can be easily dropped into your WebRTC app, so you can get up and running with WebRTC super fast. Now, we've got a special treat for you today. Chris Wilson, a colleague of ours and a developer on the original Mosaic browser, and an occasional musician as well, is going to be joining us, courtesy of WebRTC, to show off the HD video quality and full band audio quality that we're now able to offer in the latest version of Chrome. Take it away, Chris.
Hey guys.
Hey Chris, how's it going?
I'm good, how are you?
Yeah, good, good. Have you got some kind of musical instrument with you?
I do. Originally you asked me for a face-melting guitar solo.
Yeah.
But I'm a little more relaxed now. IO's starting to wind down. You can tell I've already got my Hawaiian shirt on. I'm ready for some vacation. So I figured I'd bring my ukulele in and hook it up through a nice microphone here so we can listen to how it sounds here.
Take it away. Melt my face, Chris. It's pretty good.
He's pretty good. All right.
That was beautiful. Thank you, Chris.
All right, guys.
Chris Wilson, everybody.
The audience has gone crazy, Chris. But thank you very much.
So you finish up?
Yeah, so, we've had, a fraction over 30 minutes cover a really big topic. There's a great lot of more information out there online, some good stuff on HTML5 Rocks, and a really good ebook too, if you want to take a look at that. There are several ways to contact us. There's a great Google group, Discuss WebRTC, post your technical questions. All the kind of new news for WebRTC comes through on Google Plus and Twitter Stream. And we're really grateful, all the people, all of you who've submitted feature requests and bugs. And please keep them coming. And the URL for that is crbug.com/new. So thank you for that.
So,
thank you.
And so we've built this stuff into the web platform to make real-time communication accessible to everyone. And we're super excited because we can't wait to see what you all are going to build. So thank you for coming. Once again, the slide link. And now if you have any questions, we'll be happy to try to answer them. Thank you very much.
Yeah, thank you. Oh, yeah.
Hi, my name is Mark.
Hi, Mark.
Hey.
I would like to know, because I'm using Linux and Ubuntu, how finally can I get rid of the Talk plugin for using Hangouts on Google+.
So, the question was, when can we get rid of the Hangouts plugin? And so, unfortunately, we can only talk about WebRTC matters today. That's handled by another team. But let's say that there are many of us who have the same feeling.
Okay, great.
Can you make any comments on Microsoft's competing standard, and considering they kind of hold the cards with Skype, and how maybe we can go forward supporting both, or maybe converge the two, or just your thoughts on that?
So Microsoft has actually been a great participant in standards. They have several people they send from their team, and although they don't see things exactly the same way that we do, I think that the API differences are theirs a little more low level, geared for expert developers, ours a little more high level, geared for web developers. And I think that really what you can do is you can implement the high level one on top of the low level one, maybe even vice versa. So Microsoft is a little more secretive about what they do, so we don't know exactly what their time frame is relative to IE. But they're fully participating, and obviously they're very interested within Skype. So I'm very optimistic that we'll see a version of IE that supports this technology in the not too distant future.
Very good to hear. Thank you.
My question would be, I think you mentioned it quickly in the beginning. So if I want to communicate with WebRTC, but I'm using a different environment than the browser. Let's say I want a web application to speak to a native Android app. So what would be the approach to integrate that with WebRTC?
So as I mentioned earlier, we have a fully supported official native version of Pure Connection, pureconnection.java, which is open source and you can download and you can build that into your native application. And it interoperates. We have a demo app that interoperates with our AppRTC demo app. So I think that using Chrome for Android in a web view is one thing you can think about. But if that doesn't work for you, we have the native version that works great.
Okay, thank you.
Hi, my question would be, are there any things that to be taken care between cross-browser compatibility for this Firefox, Chrome? Is there anything specific that needs to be taken care of, or it's just works?
There are some minor differences. I mentioned adapter.js covers some of the things where the API isn't quite in sync in both places. One specific thing is that Firefox only supports the Opus codec, and they only support DTLS encryption. They don't support something called SDES that we also support. So for right now, you have to set one parameter in the API, and you can see that in the in our AppRTC source code to make sure that communication actually uses this compatible protocols. We actually have a document though on our webpage that documents exactly what you have to do, which is really setting a single constraint parameter when you're creating your Pure Connection object.
Yeah, if you go to webrtc.org interop.
Yeah, webrtc.org/interop.
Right. Okay, thank you.
When a Pure Connection is made and it falls back to turn, does the turn server, is it capable of unencrypting the messages that go between the two endpoints?
No, the turn server is just a packet relay. So the stuff is fully encrypted. It doesn't have the keying information to do anything to it. So the turn server just takes a byte, sends a byte. Takes a packet, sends a packet.
So for keeping data in sync with low latency between, say, an Android application and the server, how would both the native and the HTML5 or the Android Chrome implementations of WebRTC fare in terms of battery life?
I don't really have a good answer for that. I wouldn't think there would be much difference. I mean, the key things that are going to be driving battery consumption in this case, are you talking about data or are you talking about audio and video?
Data.
For data, the key drivers of your power consumption are going to be the screen and the network. And so I think those should be comparable between Chrome for Android and the native application.
Okay, cool. Thanks.
With two computers running Chrome, what have you seen glass-to-glass latency?
Repeat?
Glass-to-glass, so from the camera to the
LCD? It depends on the platform because the camera can have a large delay built into it itself. And also, some things have, some of the audio things have higher latencies than others, but the overall target is 150 milliseconds end to end, and we've seen lower than 100 milliseconds in best case solutions for glass to glass type of latency.
Okay, and how are you ensuring priority of your data across the network?
Okay, so that's a complex question with a long answer. But the basic thing is, are you saying how do we compete with cat videos or?
No, I'm just within the WebRTC. Are you just how are you tagging your packets or?
Right. So there is something called DSCP, where we can mark QoS bits, and this isn't yet implemented in WebRTC, but it's on the roadmap, to be able to tag things like audio as higher priority than, say, video, and that as a higher priority than cat videos.
So it's not done today, but will be done.
It will be done. We also have things for doing like FEC type mechanisms to, protect things at the application layer. But the expectation is that, as WebRTC becomes more pervasive, carriers will support DSCP at least on the bit, from coming off the computer and going onto their network. And we have seen that DSCP does help going through Wi-Fi access points, because Wi-Fi access points do give priority to DSCP marked traffic.
Thank you.
So in Chrome for iOS being limited to UI WebView and with other restrictions, how much of WebRTC will you be able to implement?
So it's a really interesting question. They haven't made it easy for us, but the Chrome for iOS team has already done some amazing things to deliver the Chrome experience that exists there now, and so we're pretty optimistic that one way or another, we can find some way to make that work. No commitment to a time frame, though.
What are the mechanisms for saving video and audio that's broadcast with WebRTC? Like making video recordings from it.
So if you have the media stream, you can then take the media stream and plug it into things like the WebAudio API, where you can actually get the raw samples and then make a WAV file and then save that out. On the video side, you can go into a canvas and then extract the frames from a canvas, and you can save that. There isn't really any way to sort of save it as like a .mp4, .webm file yet. But if you want to make a thing that just captures audio from the computer and then stores on the server, you could basically make a custom server that could do that recording. That's one option.
So the Turn server is open source, but you said the Turn server doesn't capture, it can act as an endpoint. Do you have server technology that acts as an endpoint?
There are people building this sort of stuff. VLine might be one particular vendor who does this, but there's something where you can basically have an MCU, and the MCU that receives the media could then do things like compositing or recording of that media.
So presumably the libraries for Java or Objective-C could be used to create a server implementation?
Exactly. That's what they're doing.
Hi, kind of a two-part question that has to do around codecs, specifically on the video side. Now, currently VP8, WebM. Is there plans for H.264, and also what's the timeline for VP9?
Our plans are around the VP family of codecs. So we support VP8 and VP9. You may have heard that it's sort of trying to finalize the bit stream right now. So we are very much looking forward to taking advantage of VP9 with all of its sort of new coding techniques once it's both finished and also optimized for real time.
And H.264, not really on the plan?
We think that VP9 provides much better sort of compression and overall performance than H.264, so we have no plans to support H.264 at this time.
Okay.
Running WebRTC on Chrome on Android.
I advise you to do it in VP8.
Right, thank you.
Thank you all for coming.
Yeah, thank you. Thank you.
Have you wondered about the power of reshaping an industry from within? At Globit,
When I started working on embedded systems over 10 years ago, the developer experience was often determined by your microcontroller vendor, which meant writing in C, using the vendor's compiler and IDE.